Good day, everyone. Welcome to the Youth AI Talk. Apologies again for the technical difficulties at the very beginning. So we're all very excited to have you here. And before introducing today's talk, I would just like to give a brief overview of the Youth AI Speaker Series because we have quite a few new audience members here. To raise awareness of AI among all communities, we invite experts from academia and industry to share their knowledge and discovery in specific areas of AI. Unlike other technical talks, these talks will be tailored to people without much background in AI. Therefore, they're fun to listen to and easy to follow. We hope that by listening to these talks regularly, you will gain a solid knowledge of AI. So please help spread the word about Youth AI Talks. Thank you for your continuous support of this education and community service initiative. And please also consider visiting our website at the link I'm going to paste in the chat right now. And consider signing up for membership on our website, just so you can always get frequent updates and newsletters from our organization. We've hosted 16 fantastic talks since the kickoff of the Youth AI Speaker Series last August, covering important areas of AI, such as efficient AI, graphics AI, cognitive AI, finance AI, as well as different implications of AI. Replays of these talks are mostly all available on the Youth AI YouTube channel, with the exceptions of a couple talks, which are not available on YouTube due to company policy. We so far have reached more than 6,000 people with over 20,000 views through our live Zoom meetings and YouTube channel. In the last Youth AI talk, Dr. Adam Clivens, a professor of computer science at UT Austin, shared the vision for IFML and some of its educational outreach components, such as the creation of an online master's degree, along with an undergraduate research programming and online AI courses for high schoolers and working professionals. You're welcome to watch a replay of this great talk at our YouTube channel at Youth AI Lab at youtube.com, and I'm going to also paste this link in the chat below. And now I will be handing it off to my co-host and the co-president of Youth AI Lab, Clarice.
Yes, thank you so much, Melinda. So I also wanted to take this moment to announce that this August 21st and 22nd, this is a weekend, so Saturday and Sunday, Youth AI Lab is hosting a summer virtual summit in the theme of AI developments in response to the COVID-19 pandemic. This event will consist of outstanding keynote speakers, raffles, breakout room coffee chats, and more. So if you're interested, free registration can be found at the link youthAIsummit.eventbrite.com, and make sure to register for both days of the event. Melinda, I assume the link is in the chat.
Okay, just click the Zoom link.
So before introducing our speaker, Kasia Chmielinski, I'd like to briefly go over the logistics of this talk. Because we have audience watching from our YouTube, our recording, as well as on Zoom, we'll be doing Q&A through a platform called Slido. So you can either go to the URL in the chat, which Melinda will send, or go to sli.do and enter event code 172929. Feel free to submit questions throughout the talk, but we'll only be answering questions in a Q&A session at the end of Kasia Chmielinski's talk. So let me introduce today's speaker. Kasia is the co-founder and project lead of the Data Nutrition Project, an initiative that builds dataset quality standards and tools to mitigate bias in artificial intelligence. They're a technologist at McKinsey & Company and an affiliate at the Berkman Klein Center at Harvard University. Previously, Kasia was a digital expert at the U.S. Digital Service Executive Office of the President and product lead of a project of the MIT Media Lab. They received their bachelor's degree in physics from Harvard University. So today, our brilliant speaker, Kasia Chmielinski, will discuss their research initiative at the Data Nutrition Project and explain the importance of nutrition labels for datasets on AI algorithms and how they encourage responsible AI development. Let's give a warm welcome to Kasia Chmielinski. You're welcome to share your screen at this moment.
Great. Hi, everybody. Thanks so much for joining. I think it's the evening on the West Coast and then even more of an evening on the East Coast. So I see some friendly faces here. I also just want to thank Clarice, Melinda, and Ainsley for inviting me and putting on this amazing Youth AI Lab. It's such a great project. I was on your website and then I remembered that Some of you are still in high school and college, and I was completely blown away. I feel like I'll be working for you in about 3 years, so keep up the good work. I'm going to jump into a talk here. I'm going to try to keep it as informal and as interactive as possible in a webinar format. We'll see how well I do with that. So I'm going to just jump straight in. I think once I do this, I can no longer see all of you very well. So if there's anything that goes wrong, please let me know, because I won't necessarily be able to tell. Okay, can you see my screen okay? Thumbs up?
Yes, all good.
Perfect. Okay, so as I said, my name's Kasia. A little bit of background on me. I have a degree in physics from about 1 million years ago. After I studied something fairly technical, I went straight into something very non-technical, and I studied I worked in communications and strategy at a little company called Google back in the early thousands. Founded a company that actually works in AI, fintech. Ended up going to MIT working on something called Scratch, which is a kid's coding language. And then I jumped into federal service, and I worked at the government in the executive office of the president, doing some work around opioid data and visas. And most recently, I kind of split my focus, went to McKinsey, joined as a product manager, building technology for healthcare, specifically in healthcare analytics, which was kind of sleepy. And then COVID hit, and then it was no longer very sleepy. In fact, it was sleepless. And I also, at the same time, run a group called the Data Nutrition Project, of which I'm a co-founder and a lead. I'm going to talk mostly about that today. So yeah, let's talk a bit about bias in AI. Now, my understanding is many of you on this webinar are going to know a lot about AI, but I want to make sure that we start at the very foundation here. And when we're talking about AI today, we're really talking about narrow AI. So if we think about the various kinds of AI out there, you know, there's kind of the Terminator, which is what a lot of people say when you think, what do you think about AI? And they say, oh, the Terminator, right? And that takes knowledge from one domain, transfers it to another domain. You have a smart robot that can act like a human, but is stronger and smarter and better and scarier. Then you have super AI, which is like one step beyond that. We're not even sure really what that means. We're not in that phase right now. Either of those phases. We're really in the narrow AI phase. And what that means is that we're teaching computers and we're training computers to assist with specific tasks, right? So that would be Alexa asking Alexa questions. Oh, my Alexa just turned on. Self-driving cars, right? So asking a machine to drive us down the street. We're not asking that machine to then also go and do our taxes, right? We're saying you have a particular task and we're asking you to do that. And that's what we're training you to do. And so when we're talking about AI today, we're talking about narrow AI. And the issues that I'm going to talk about all kind of pertain to that category and not some of the bigger kind of existential crisis or philosophical issues you might have with the general AI or the super AI. So I hope that's kind of clear there. Now, I'm really a fan of adorable things. And so this slide is a serious slide, but also features a lot of really adorable things that are actually food icons. So what I like to say is that in AI, you are what you eat, right? So algorithms are using training data to help them understand the world. We're training them with a bunch of data. They start to see the patterns in that data, and then they can predict the future based on what they've learned about what you've fed them. So in this picture here, we have our cheese wheel in the middle, which is our algorithm. And I'm feeding it all kinds of information about other kinds of foods, right? So I fed it some pizza slices, I've got some pears in there and some popsicles. It's a very balanced diet. And then in the future, when I present that cheese wheel with pepperoni pizza, it says, I know pizza, I've seen pizza. I know popsicles, I've seen popsicles. I know pears, I've seen pears. But what on earth is that? I've never seen a radish before. There's no way that I can tell you that it's a radish. And that's kind of at the fundamental level what my group is thinking a lot about, which is what do you do when the data that you've fed the algorithm doesn't necessarily represent what that algorithm is going to experience in the world? And what kind of ramifications is that going to have on the way that you use the algorithm and the output from that algorithm? So if we make this a little bit more real, right? Food is fun, it's adorable, icons are cute, but these are real world problems, right? And AI systems that are built on incomplete or biased data are going to exhibit the same issues in the data that we fed it. These are just some recent examples of things that have gone wrong with AI, right? And it's based on bad data or biased data that we use to train these AI systems. So on the left-hand side, you've got predictive policing algorithms. These are algorithms that are used to help police forces decide where to deploy more police. So the way that these things are trained are, they say, okay, well, let's take arrest records and we're going to train the algorithm with arrest records and say, what areas had more arrests? And based on where more people were arrested, we're going to assume that that means that there's more criminals there. And then we're going to send more police into those neighborhoods. That's how the algorithm is making decisions. But if we think about that data, right? Think about arrest records. Not all people who are arrested are criminals, and not all criminals get arrested. We actually know that a lot of police are sent into communities of color, for example. They're actually more strongly policed, not necessarily because there's more criminality. There are a lot of other reasons, for example, racism. So these algorithms start to make predictions about where to send more police based on where there are more police. And that there is, ends up being kind of a bad cycle that we get into there. I'm not going to go into too much depth in these other examples, but the one in the middle is about suicide risk prediction models that are built on historical behavioral health and mental health data. And that data actually doesn't capture all communities, because in this case, a lot of communities don't have access to mental health support. And then on the right-hand side, Amazon created a hiring tool that was built and trained on historical hiring data. And it turns out that historically, not all communities were hired equally, especially gender, right? So especially women. And so this new hiring tool that was built on kind of historical data immediately started to discriminate against women, because resumes would come in, they'd say, we haven't really hired a lot of people who look like this in the past. So we're going to say, don't hire this person. And that happens to be, overly representative of the female population. So these are real problems, right? So you are what you eat, and if you are fed something, or you're not fed something, there's no way that your health is going to kind of exhibit that when you're then out there making decisions in the world. So I'm going to do this very risky thing where I'm going to try to build a live example on this call. So let me jump over here. I'm going to move you all to this corner. All right, so you should be seeing my whole browser, I hope. We're going to jump over to Teachable Machine. You see this? Yes? Good? All good? Great. So I did not build Teachable Machine. This is a Google product. It is not going to save the data that I send into it, hopefully, I believe. And I'm going to create an image project. Now, I'm going to do this relatively quickly because I don't have too much time. I want to make sure there's a lot of time for Q&A at the end. But essentially, I'm going to build an AI that's going to see pictures of me and classify me one way or another. And we're going to see what happens when I feed it okay data and then better data. So I'm going to go into a image project. I have two classes. We're going to build a model that's going to predict whether or not I have a mask on. So we're going to call this yes mask, and we're going to call this no mask. All right. Right. So we turn on the webcam here. You should be able to see like me multiple times now. Great. And mask. So this is also going to be tricky because I have a headset on, which is something I hadn't really considered. But I'm going to put the mask on. Hopefully this won't be terrible. Okay. And now I'm going to take pictures of myself. So we've got some training data of me with a mask. And then I'm going to pop down here to the no mask. I'm going to take a few pictures of myself here as well. All right, I'm going to train that model. So that model is training, and it should now have two different classifications, me with a mask, me without a mask. It should be able to, okay, we'll train for a second. This is going to take longer each time. AI takes a lot of computational power. Okay, so it's now looking at me, right? And it's saying the output, it's 100% sure I don't have a mask on. Pretty good. All right, let's put the mask on. Let's see what happens. Okay, it is 100% sure I have a mask on, and you can no longer hear me very clearly, so I do have a mask on. Now, let's see what happens. I put on a different mask. So my other mask, a friend of mine made, stormtroopers, pretty cool. So I'll put this on. See how it does. All right, pretty good. But I noticed that while I was putting this on, it was having some difficulty. Wait, hold on, no mask. Oh, no mask. Oh no, it's not very, okay, it's having some issues here, especially when I move my head around. So that's interesting. So it doesn't think I have a mask on. Now it does think I have a mask on. Now that's interesting. We'll get back to that in a second. Let's see what else we can do. Now I'm gonna throw at a curveball here. I'm gonna put on these really cool glasses that I stole from my niece. Okay, now it really doesn't know what's going on. It's kind of saying, maybe you've got a mask on, it's kind of in the wrong part of your face, I'm not really sure, right? And so in this case, I'm gonna not play with this anymore. Basically what we have is a situation where it's got a bunch of radishes, right? It has never seen a lot of what we're throwing at it right now. And so it has to make a guess on some data that's not very good. And one of the big components here is that actually I only took a picture of me facing, right? So if I put this mask back on, maybe we can make the algorithm a bit better. All right, so yes, mask, but if I start to change my head around, you can see it's saying no mask, it's saying I don't know. So we're gonna go back to yes, mask. And we're gonna record some more with me moving my head around. All right, we're gonna train the model now and see if that makes a difference. Okay, so ideally what we'll see here is it gets better as I feed it more data that covers more of the use cases. So it's me, there we go. So now as I'm moving my head around, all of a sudden, it's having a lot fewer issues, right? Because I updated that particular chunk of data. But if I put the glasses on, still confusing because I haven't added any additional data that's going to help with diagnosing whether or not I have a mask on when I have glasses on. I feel like I should just leave these glasses on for the rest of the presentation. What do you think? Okay, so that's the live demonstration here about building a model and what it means to have data set that is actually representative of what happens. Now, these are kind of silly examples. I got glasses on, I have different masks, different color masks. My head is in different, you know, I'm changing the angle at which the camera sees me. But you can imagine what the ramifications could be if we think about a few more maybe serious issues here, right? What about people who don't look like me? What about people with darker skin color? What about people with different colored eyes? What about people with different colored hair, right? And so as we think about things like facial recognition or models that are built on images around people, we have to start thinking about representation. And a lot of the teams that are building AI don't look like the world in a representational manner, right? They are a particular demographic. And so as they're testing these models in the lab, it's not malicious, but they're probably not testing all the possible outcomes. And so they don't catch the things like, oh, I need to move my head around, or I need to take pictures with my glasses on and my glasses off. Okay, I'm going to pop back over to my slides. All right. So can we do anything about this? The quick answer is yes, otherwise I wouldn't be here to talk to you. But no, we haven't figured it all out. So there is an opportunity to think about data quality before we build the model. Now, obviously, if you go through the whole model build, and this is a pipeline here about building AI, you have your data set, your training data set, right? You pre-process that data. You take a lot of time doing that, cleaning up the data, adding missing data, you know, trying to add additional chunks to fill in things that are missing, going through cleaning up errors. Maybe you have formatting issues. Then you develop your model on that training data, and then you deploy the model. Now, if you find an issue like we did once the model is already built, that's actually quite expensive depending on the size of the model. It's really expensive to go and change the model at that point because you've already gone through that whole pipeline. And that can be millions of dollars and dozens of people, right? So what could we possibly do to interrogate the data quality at the beginning? And this is really the question that my team had. So sorry about that. I promise I'm not dying. So what we did when we first started our project, it was a few of us. We were in a fellowship at MIT, and we were thrown a question like, what can we do about the governance of AI and the ethics of AI? And so as a team, we sat down and we said, well, you know, we're all technologists. All of us have built AI in industry. We should go talk to more people and say, what do you do about the quality of data, right? So in this step right here, when you go between the data set and the pre-processing, what do you actually do to determine whether that data set is fit for the use that you want to use it for? And so we asked a bunch of people, we did a huge survey. This is what we heard. It's a total free-for-all. So there are no standards. There's no standard process that you'd go through to decide when you pick up a data set off the internet, is this actually good for the thing that I'm trying to build? And so we thought, hey, that's a really good opportunity for us right there. We're going to try to launch a poll right now. Oh, fantastic. My goodness, you're so fast. Okay, so this is a question about nutrition labels on food. And I'd love for you to take a look and honestly say what your relationship to these labels are. The first is, I have no idea what you're talking about. I do not know what a nutrition facts label is on food. The second is, I know they exist. I've never really read one. The third is, I look at them, but doesn't change what I do. And the fourth is I read the labels and I've made decisions whether to buy something or eat something based on what those labels say. So take a few minutes here. Please don't be shy. We have no idea who you are. Genuinely interested in what you have to say here. Okay, I'm guessing that we've got most of the responses now. Super interesting. So it sounds like we're kind of leaning towards options 3 and 4, which is that people know that they exist, or really 2, 3, and 4. And, you know, people understand that they're there. For some folks, you know, a third of folks here actually have made decisions differently based on those labels. So that's pretty interesting for me to know. And I will show you why in a second. I'm going to close that poll there. Okay, right. So why is, oh, and let me share the results so you all can see that. Hopefully you can see it on your screen. So that is what we see in terms of the distribution here. And that's actually really something that as a group, we decided was powerful. We thought about the ways in which transparency into something can change behavior. We immediately thought about the nutrition labels on food. And we thought, you know, even if people don't make changes to what they do based on those labels, most people know they exist. And so wouldn't it be awesome if there were something similar for a data set where when you pick up a data set, you also can look inside before you decide to eat it, right? You can decide based on what's on the outside of the data set, whether it's going to be healthy for your model to eat that, because you are what you eat, right? And so is your model. And when we did the research around whether these labels are actually useful, there's actually a fair amount of academic research that supports that people actually make different decisions when they have more information and it's presented to them in something that's easy to read and compare, such as the nutrition facts label. So we decided to jump in and just try to do that. So the Data Nutrition Project is a research group. This is who we are. I'm just one person of many smart people. They're actually generally smarter than I am. We are trying to empower data scientists and policymakers with actual tools. There's a lot of people talking about this, and we're actually trying to build things that we can deploy that will improve AI outcomes in an inclusive and an equitable way. So we really try to build and deploy and be the things that we talk about, which is that we want tech for all, and we want tech to be used to the benefit of society as opposed to the detriment. What we came up with, this is the second version, and we launched, let's see, last year. what year is it? Who knows? It's a pandemic. So recently, we launched this version of the nutrition label for data sets. And what it has here is basically an overview of the data set, some high-level information about what is contained or things you might need to know about it, the way that you might want to use this data set, and also alerts that you might need to be aware of when you decide to use this data set, or if you do. And actually, let me just see here how much time we have. Yeah, okay. Let me actually show this to you. I think that'd be fun. I'm in the mood to just kind of show you things. Demoing live is fun, right? So this is our website, so feel free to peruse it at your leisure at some other point, datanutrition.org. And if you go to see the label, you can actually go to the label and you can see a few examples of ones that we've built. This one is the same as the screenshot I just showed you. This is a data set of images of skin lesions, so areas on skin, that is used to classify melanoma. Melanoma is cancer. So the Memorial Sloan Kettering Cancer Center in New York partnered with us, a really amazing doctor named Dr. Rodenberg, who's thinking about melanoma and detecting melanoma, but in particular, what this means when you have a bunch of pictures of skin that is not very representative. There's not a lot of darker skinned individuals or lesions really that appear in this data set or any data sets anywhere. And she's very aware of this and wants to make sure that she improves that over time. So we worked together to build a label for her data set. And I'm gonna get a little bit, maybe I'll just like boost up a little bit. So what you see on the label here is you've got an about section, which tells you why this data set exists. It gives you some metadata It also tells you what the use cases would be. The big algorithmic use cases would be to identify melanoma. So essentially you'd give a picture of the skin to the machine. The machine would say, yes, cancerous, no cancerous, and would be trained on this data set, which includes both cancerous and non-cancerous images, or images of cancer and non-cancer. Also to predict the incidence of melanoma in a population, which is actually probably, you have to know some things about this data set in order to use it correctly that way. Badges here, it's about humans. It is not aggregated at the individual level. It does include subpopulations like gender, and also there's a scale for skin tone. It has not been quality reviewed. It has not been reviewed for its ethical use. It can be used in a non-commercial way. It's been funded by many sources. The data comes from one source, and it's not actively maintained. So these are kind of high-level things that we feel you can compare, and you should compare across all data sets. One example here would be if I was trying to build a melanoma classification algorithm, and I may be looking at 3 or 4 possible data sets, I might want to compare their labels as a way to compare them. So I'd say, oh, this one, I actually can't use this in a commercial way, but this one over here, I could use and then sell that. And that's what my business model is. So I want to use that one instead, right? So this gives a really quick way to compare data sets. And then the alerts as well. I'm going to jump into the alerts. So there's a section here called objectives and alerts. And this is saying, what is your modeling objective? And based on your modeling objective, like if this is what I'm trying to model for, it will show you the alerts that are relevant to that particular modeling objective. And so this one was one that I mentioned before, which is the data set is not representative with respect to darker skin types. So this is not something that you can mitigate because it's missing a bunch of data. It's about completeness, and the potential for harm here is racial bias, since in this country and in others, race is often tied to skin color. Gives about a bunch of information here and just basically flags it for you. So if you're a data scientist who's trying to calculate, performance versus anatomical site, that's your modeling objective. These are things you need to know. There might not be a mitigation strategy, but it's something you could test for and something you could look for and try to mitigate, maybe by bringing in other data or by making sure you have a big warning label on this so that people understand that it's going to be more accurate for some skin types than for others. And finally, there's a dataset info, which is kind of like the longer list of questions that we ask everybody who has a data set, who wants a label. And it gives you kind of more information. So if you wanted to figure out, for example, who's managing this, you can see there's some of this is still question marks here. There's, is there a mechanism that people can request their information removed? The answer, unfortunately, is I don't know. And so this right here is obviously a draft that we're working on. Okay, so that is the label. This is actually, I think, a good time to do a second poll. So if you wouldn't mind launching that. So I don't know exactly who, thank you. I don't know exactly who is on this webinar right now, but I'm wondering, for those who are data scientists or build AI or think they might build AI, what do you think is the most useful part of the label that I just showed you? Is it the description of the data set? Who owns it, where it comes from, who paid for it? Is it the alert section about the known issues? Is it the badges so you can quickly scan them, or is it something else? And if something else wins, I'm not even sure what I'm going to do with myself because there's no way for me to find out. Great. And this is kind of, as these results are trickling in here, I'm seeing that majority here are saying the alerts and the badges are very useful. And that's kind of what we hear from data scientists as well. Let's see, why don't we call it, and we can just share these results so people can see. Awesome. And this is aligned with what we hear from folks, which is that a lot of data scientists and people who are analysts don't have a ton of time. They're given, okay, your deadline's Tuesday, and it's like Monday night. And so they have to go out and find the data, decide whether or not it's good for what they're trying to do, and then build a model really, really fast. And since the turnaround time is so fast, people really want to understand quickly, like, give me the basics of this. In the same way the nutritional label on food is just going to say, fat, carbs, whatever. The kind of description, folks who have a bit more time, researchers in particular, journalists are really interested in understanding more about the data set. But this is definitely aligned with what we've heard. So thanks for partaking in that. Okay. All right. And I think I'm finishing up here. So let me just share these last few. So I just wanted to say a bit about what the impact has been so far of what we're doing. So we have done 2 versions of the label. You just saw the most recent. We break it down into several different components because we have many different stakeholders here. In terms of the approach of making sure there's transparency into data sets and how they're used and how they should be used and should not be used, we've talked to all the major companies. I've put their logos here informally, right, just to say, what are you folks doing? What are we doing? There's actually a lot happening inside of companies around kind of almost like self-regulation. And so we've had a lot of really, really great conversations with folks in all of those places and more, including governments and folks who put out open data, open standards community, et cetera. In terms of the methodology, we're actually starting to be integrated into some of the certifications that are showing up around AI. An example here is the RACE certification from the Responsible AI Institute. They have a end-to-end system certification for AI, and the data component of it is leveraging DMP. So that is pretty cool to see. And finally, as a standard, this is a conference, it's a very nerdy conference called NeurIPS. And we're starting to show up as one way that people who are submitting academic papers can show that they have thought about data quality standards for the data sets they've used for their research. And so that's also very cool to see. So our long-term vision here, we really think that having additional transparency on data sets is going to drive robust analysis practices because it's faster and easier for folks to actually see what it is that they're working with before they dive in, before they make a mistake, before they deploy a model. Therefore, it's also going to increase the quality of the models because better data and more transparency means better models. And finally, and we saw this with the melanoma data set, it's going to enable the creation and publishing of better data. It's kind of like if you are making a, a candy bar or something, and as part of the candy bar, I was going to say launch, production, you have to create the nutritional label, and then you think, oh, my competitor, let me go look at their nutritional label, and then you're like, whoa, our candy's like really not good for you. You might actually change what you do in terms of making your candy because you know what the expectation is of the market. And so that's also what we hope to do down the line, is that people are going to make better data because they know that they have to, at the end, be transparent about what's inside of it. So that's an overview of kind of the state of bias in AI, how we have approached it, our little slice. We are part of a much, much, much larger ecosystem. And I am very happy to have been able to share this with you, and I would be even happier to answer your questions. So thank you so much.
Thank you. We're definitely also very excited that you came here today. That was definitely a really good talk of discussing the importance of these nutrition labels for data. I definitely think it's really important for us to realize that with people feeding these bits of data into AI, that there will also be biases that come along with it. And in order for us to create fair data that's that can basically attribute to everyone, that we need to basically sort of notice these biases and also find ways to combat them. And I really think your team is doing a great job of that. So thank you for the talk. I also really like the radishes. But yeah, now moving on to the Q&A. We have one question in Slido that I'm gonna go ahead and ask first. So Anonymous asks, based on your experience looking at big data, what is good gender classification questionnaire that one can use in their research studies?
Yeah, this is a really tough one. Before I answer that directly, indirectly, I think there's a larger question around kind of observable and unobservable characteristics. So if you're kind of assuming that gender, well, first of all, there's a difference too between sex and gender, right? And so being clear as to what you mean by that. Like, for example, my sex is female, but my gender is non-binary. So these things aren't necessarily aligned, right? And then what you're going to be doing with that data is also important to consider. Do you need to collect that data? And if you do, because you're actually trying to make sure that things end up being fair, you'll want to make sure that you word things appropriately. And I'm a huge fan of letting people write things in if they don't fit the buckets that we have in society. I think to answer the question a little more specifically, which I think was about gender and not sex, I've found that I appreciate it when there are kind of the male gender, female gender options, and then kind of third or non-binary. And I think other with a write-in is also very nice because it allows people to kind of identify the way that they do identify. And then you have to decide what you're going to do with that data and how you're actually going to implement. But that would be my response for now. And I don't know if folks can come off mute or something, but I mean, I'd be happy to hear responses to that or other ideas too, because I don't have the answers to all these things.
Thank you so much for that response. I actually have a question for you regarding the beginning of your presentation. You talked about narrow general to super AI. So when do you think we'll be able to reach the point of general or even super AI? And like what would be the turning point to reaching there?
Wow, I don't think I've ever been asked that question. I feel like I should ask you folks. You're probably gonna be the ones that do it. I don't think it's, personally, I don't think it's gonna be like a big bang moment. I think that what we're going to have is narrow AI that gets less and less narrow. So we'll have an AI that was built for one particular task, but it will start to be good at a few tasks, and we'll add more and more tasks to that, and then eventually it will become a little bit broader. Maybe not general, like it can answer any question, but it can do a certain series or a bucket of tasks. And I think that it's going to be a little bit slow in terms of when it creeps up on us. Right now, people a few years ago would say, I have nothing to do with AI, I don't know anything about AI, and they get in their cars and plug in Google Maps and directions, and that's AI, right? So I think we've gone from, I don't even think there is AI, to, okay, no, I am outsourcing some of my thinking and my decision making to machines. And I think there's going to be another shift where those same machines are going to be able to do a number of different tasks for us, up until the point where it's going to become something that starts to approach generalized. I don't know like what that moment is when you have a machine that suddenly is as smart as a person in everything. There's probably some piece here where eventually you'll have a machine that also can learn very quickly so that it's adapting all the time, and that will feel much more generalizable, right? But that's my answer there. I don't think there's going to be like a big bang moment, but again, I don't know. If I had the answers to these questions, I would be very, very rich. It's a good question. That's a really good question.
Right, definitely. These questions are very profound in a sense. And I guess I also have my own personal question. It's not as profound as Clarice's, but I noticed when you were sharing sort of the nutrition labels for the data set on cancer, there were sections, like there was a section on gender bias, there's a section on like racial bias, and there was another section I saw that was on socioeconomic bias. So I'm wondering, I guess, how that's identified through images, since I'm assuming, I might be wrong, but with like usually with skin cancer, you're uploading images of various different inputs. So I'm wondering how socioeconomic class is identified with AI.
Yeah, that's a great question. When we were thinking about the different categories for, let me take a step back. So one of the biggest challenges for making a nutrition label for a data set is that it's not food, right? So the analogy breaks down when you start thinking about, well, how many different kinds of data sets are there? There's different types, there's different sizes. There's, trees in Central Park is very different from humans and cancer. So how do you build one label that's actually going to scale across all of these different kinds of data, right? And so in that way, it's not food, because with food, it's like, it's all, it's got all the same components. We can list them on a little grid and there you go. And so one thing that we had to do was think about, well, if we're going to capture potential biases or sites or harms, potential harms, how do we actually want to do that? How do we want to categorize that? What are the right lists of types of harms? How do we define that? Honestly, we're already working on V3 because we were not satisfied by V2. So we're still kicking around these questions. We've decided, though, that there is a lot of precedent in like civil rights law and in activist circles, right, around how to quantify and identify harms. And a lot of that has to do with protected classes. So we've gone back to a number of the definitions around who's protected in what case and why, and we've picked up those particular buckets, right? So that is gender, sexuality, race, socioeconomic status, age, like a certain kind of subset of categories that we know exists and is relevant when we're thinking about civil harms and kind of rights, right? So we've picked up those buckets and used those. Now, in terms of your actual question about how the data set, the melanoma data set, might have socioeconomic harms attached to it, one example might be like whose images are represented. These skin care centers and these skin cancer centers, do they actually open their doors to everybody? Whose images are actually represented here? How do they get those images? In a lot of cases, you have to kind of be rich to have healthcare, unfortunately, especially in this country. And so you might not actually have a good representation at a socioeconomic level because of the way that the images were collected and who is represented in those images. And you'll never really be able to tell that from the images themselves, which is another thing that we kind of battled when we were initially setting up the label, which is who's making the label. And it became evident to us pretty quickly that we would need to have a really strong partnership with the group or the person who actually built the data set in order to answer a lot of these questions. It's hard to look at a data set and say, what's missing? Because you don't know. By definition, it's not there. And unless you look at a bunch of rows and columns and you see actual missing cells, conceptually, it might not be a table like that, but that you could say, okay, there's a hole, I know, right? But if there's an entire population that's not represented, that's not a column or a row, that's just missing. And you will need to have information from the person who created that data set, is hosting, maintaining, paying for that data set in order to get access to that kind of information. And so back to your question, can we look at the skin images and say, oh, there's a socioeconomic bias? No, I mean, you're looking at images of skin, right? There's not like a dollar sign on that necessarily. But if you go and you ask the people who curated it, you say, where'd you get this data? Who's represented? Who had access to these services, right? What zip codes were you in? What countries were you in? Was it government sponsored? Did insurance cover it, right? These kinds of questions. Then you can get at some of these underlying issues around, for example, socioeconomic bias.
Yeah, thank you so much. It's really cool how so many underlying aspects of data we just don't realize at first can have these biases show up in the data set. Another question that I had was, I wanted to ask from, for example, a consumer's point of view, if they're interacting with, let's say, a recommender system that uses AI, should the developer also provide the nutrition label of the data to the consumers of that recommendation system?
That's a great question. And you're kind of getting to a question we kicked around a lot, which is like, who is the user of this label? So if you're in, product management land, which is where I spend most of my time developing new products and things like that, one of the big questions you have at the very beginning is, who am I? Well, why am I building this thing, right? And whose problem am I trying to solve? So who's like my target audience with this? So when we were building the label, we had the same question, which was, it'd be really great to be able to make this label so accessible that someone could read this whose data is in the data set and they would understand the impact of their data being part of the data set. But our primary user is actually the data scientist that's coming to pick up the data set and trying to decide when she's looking at that data set to make a decision about building a model, is this or is this not good for the thing I'm trying to do? So we've really prioritized the data scientist. It doesn't mean that a consumer looking at this wouldn't find something interesting. And we have thought about kind of like an adjacent user to that, the researcher or the journalist who's kind of like providing information to the public and also making sure that that person can read this, that this label is legible to that audience as well. So to your question about whether someone who's building a recommendation engine should have to say where the data came from, I think yes. I think actually there will need to be, or there will be legislation for particular kinds of AI that are high risk, that AI needs to be explainable. It needs to be transparent. The data that it was trained on needs to be explained as well and made transparent. And the label can actually be a real help for that, because a lot of companies will say, I can't give you the data because it's proprietary. That's my data, right? Like I collected that internally. That's, trade secret. that's not fair for you to say I have to expose all the data, because that's my secret sauce. If I put my data out there, then another company could just take that data and build something like that I have, right? And that would be bad for my business. So that, I think, is a pushback that we've seen when people say you have to say what's, how you train this model. However, if you have something like a label, the label could act as a proxy. So instead of putting the data out there, you can actually publish the documentation for the data set and say, I'm not going to give you my actual data, but I will tell you, I'll be transparent and tell you where the data came from, the kinds of things it contains, the types of biases we've identified, etc. So it's actually, I think, number one, legislation. I think we're going to have some regulation around this. And I think that is exactly where this is going. And number two, the label can actually help with that, because otherwise you might never see that kind of transparency based on, needing to retain IP at the company level. I hope that answers your question.
Definitely, yeah. I think another thing I just wanted to mention before I asked another question, Slido. So for those people who just sort of trickled in, because I noticed some other people coming a bit late, I just wanted to remind everyone that in order to basically submit questions, since we don't have the Zoom chat on, unfortunately, right now, we're doing Q&A through a platform called Slido that my co-host Clarice just pasted in the chat. So if you have any questions, feel free to just ask them there and they will be answered if time commits. So for the next question, oh, I lost the tab. Oh wait, okay. Okay, so Anonymous asks, how do you plan to get all these data sets to participate and adopt these nutrition labels?
That is it's a hard-hitting question, and we can't just go and ask them all nicely. Yeah, so we thought a lot about this, and something that's very heartening that I've seen over the last few years, just since launching this project in 2018 or whenever it launched. Something very heartening is that a lot of people want to do the right thing. We have a lot of people who are working on AI who are concerned about the impact of AI, the potential impact of AI, especially negative, and excited about the potential positive impact. There's a lot of positive impacts as well. And people are saying, hey, I want to do the right thing. Help me, right? Like, let's work together. None of the labels that we did prototypes for, did we go in and like twist people's arms and be like, build a label with us, right? Like, they were all really excited. Actually, half of them approached us, right, and said, can you help us do this thing? We really want to do this thing. And so our strategy so far has been to say, let's identify the buckets of data out there that is put out there by people who want it to be used correctly. So when we think about government data, we think about open data portals, places that already put out a ton of documentation, try to do the right thing, make sure that there are data dictionaries and all of that. So governments, academia, right, benchmark data sets, places where they do data and they want to do it well. That's probably the first place that we would start. It will be hard to get folks who don't intend to ever share these kinds of things or want to. It will be hard to make them do anything because we can't. Now, there are kind of two approaches at that point, right? One is that there is an expectation that this label or something like it will be available, because data scientists start to say, where's your label? They come to use the data set and they're used to the label on other things. And they're like, show me the label. Like, in the same way that you walk into a bakery and they don't necessarily put a nutrition label on their croissant because they baked it. And you might start to think to yourself, I wonder how nutritious this is. And then you might ask, hey, do you happen to know like how many, I don't know, calories are in this thing? Right? And you might just start to, as a consumer, you might start to drive that behavior because you expect it. That's one thing that could kind of push people who are a little reluctant to put labels or build labels to make them do that. The other, obviously, stick is regulation and legislation. So you could imagine a world in which if you want to publish a data set, it has to have a label with it. If you are going to use a model, you have to explain where the data came from, and that data has to have a label on it. Right? You can imagine these kinds of mechanisms that start to come top down. So we are currently, we're a scrappy team. We're working bottom up with folks who want to do this. And then we're kind of hoping that top down, you'll either have like a consumer push to do this, or, you know, data scientist push to do it from a cultural perspective, or there'll be some kind of regulatory body or decision that comes down that kind of forces it a little bit.
Thank you so much for your thoughts on that. Yeah, it's pretty interesting. And we do have another question from Slido, actually. And a member of our audience is wondering, given that some governments are requiring builders to construct mixed housing, how do you think AI will be able to tease out socioeconomics via zip codes or postal codes?
Let me read that to myself again. Give me one second. I think governments are requiring builders. Right. Well, okay, so I think this is getting at a few things. I'm not sure I completely understand the question, but definitely zip and postal codes in the US are used a lot as proxies for race and also income. So in the US in particular, but also I believe in other countries, I've worked in Europe, and it's the same in some European countries as well. A postal code or a zip code often is a pretty good proxy for various elements of the population around that region. So lower socioeconomic status or income, different races or communities, etc. So I think that definitely, you know, for example, I worked on some COVID response over the last year. And in a lot of cases, we didn't have a ton of data because demographic data was not being collected. So, you know, when you are trying to vaccinate an entire population of millions and millions of people, collecting specific demographic information is probably not the top of mind for you. You want to like get jabs in arms. And you're not thinking like, well, how does this person identify? And should I ask them? You're just like, I'm tired and I need to vaccinate as many people as possible. So what you end up with are data sets that are incomplete with respect to things like race. And a very common way to use AI in these situations is to actually use something like zip code or surname or first name to kind of impute or create that missing data and make a guess, like a probable guess, to fill it in. Just to say, all right, if we're just going to guess, make a best guess based on what we know, what can we see with respect to the distribution of who we're vaccinating, who's getting tested, who's getting sick, etc. So I think the same could probably be done for housing, where you could take the areas where the housing is going, and you can probably take a look at zip code, and you can kind of impute who is there and who's likely to live in the housing and who's not. I think take it with a grain of salt though, because it's always dangerous to create data and it's always dangerous to use proxies, right? Now, if you're, for example, if you're using census data in the US to do that match, so you're looking at the racial distribution in Jersey City, where I live in New Jersey, and you are looking at my zip code and the people who lived here, the latest information that you can get from the census is 2010, because they haven't released 2020, right? So you're now looking at data from 10 years ago, and you're imputing a bunch of missing data based on demographics 10 years ago. A lot could happen in 10 years, right? So I would say that's how I imagine AI could be used in that case, would be to use zip code, last name, whatever, as a proxy for filling in some of that missing data so you can make the best guess that you can. I would also just say, as a warning, it's always better to get actual data self-reported and get closer and closer to that source while still, of course, maintaining privacy so that you actually know what's happening, not just some approximation of reality.
Definitely. I think that's actually a fantastic answer to that question. Unfortunately, we are running out of time. We've reached the 6:30 mark. I'd just like to give a quick thanks to the speaker. Wonderful talk. And I think it's really important to actually sit down and realize the many multitudes of layers that these data sets actually contain, and how we're looking at these complicated data sets and how we need to make them in order to actually represent people so that they can actually be utilized in the real world, so that more people can be helped and more people can have access to this data, and data scientists as well can also be supported by this. I think that's definitely really important. And I think you and your team are doing a fantastic job already. And I really like the idea of these nutrition labels. And just a quick note, since today, I know we had some technical difficulties at the beginning, and I also noticed that people at the end were also sort of trickling in at the end. So we will be having this talk posted also on our YouTube channel since we were not able to live stream it today. So if you do want to watch the replay, it will still be up on our YouTube channel. Might take like a couple 10 minutes or so for it to be uploaded after this talk. And also don't forget to check out our summer summit that is coming up at around the end of August. So look forward to that definitely, to interact with more wonderful speakers such as Kasia, and thank you for everything. Thank you everyone for coming today.
Thanks so much for having me.
Thank you, everyone. Kasia, do you
and-
mind staying behind a little as well?
Yeah, absolutely. Yeah, thanks so much, everyone.
Thank you everyone for coming today.
Melinda, do you have the recording? Do you mind pausing
I
that?
do have the recording. I can
Okay.
put that on